Hi everyone. In today's video, we are going to be talking about counter. A counter is a built-in data structure that counts the number of times each value in an array or list appears. Hash table objects are counted using the counter subclass. Counter object constructs an iterable hash table when called. For importing counter, we use the counter. It is in collection module. This is a simple list of integer value and we have declared a counter object. Run the program. You will see we have 1 3 times, 2 twice, 4 2 times and 3 only once. So this counter object actually returning a dictionary of all a distinct key and their counter values. We'll just see another example. This is a other list of characters. Similar type of dictionary we are going to get with their count. You see, A has 3 times here, C has 3 times, B has 2 times, and D only once. If you want to declare a new counter with empty values, you can easily get it, right? In the program, you will see counter is just empty. For example, we have this string. We have created a counter object. If you print it, we'll see the same type of output. We are getting a dictionary with the keys and their count. We have just set students and courses and their counts. This way, counter can also be initialized. Okay, if you're in the program, you will see the same type of output in a dictionary form. There are other ways to create a counter instances, however, they don't strictly imply counting. If we create counter object like this, it doesn't mean that we are counting. Okay, in the program, you will see the same output. Let me remove this. We are going to access and modify counter elements now. Okay. For example, we have a counter object in this form. Okay. We have character values in a list format where we character is getting repeated. Okay. If you're in the program, you will get B2A1. If you want to access a specific element of this dictionary, then you have to just say print C and say A, B. And the program, you will get 1 and 2. For A, we have only 1. For B, we have 2. We can also modify the count of an element by assigning a new value to it. You have to set the value. Now, if you print the A, you will get a different output. You see, if you print the complete object of counter, so it will modify it. You see, let me remove it. If you want to print any element from the C object which is not exist, you will not get any key error exception. In the program, you will get only 0. Okay. And even setting a count to 0 does not remove an element from a counter. If I am setting A as a 0, it does not mean that we are going to remove this A element from this counter. Okay. You see, you will get A values as 0. Okay. We are not removing it. But if you want to remove an element from counter object, you have to use del keyword. Okay. I'm going to say del C object and A. Okay. Then you will print C. So this A element will not be appeared in the counter object anymore. Run the program, you will get only B, right? A is removed now from the counter object. Now let's see update function on counter instance. I'm removing this. I have code a snippet. Let me run the program. So it will just showing this dictionary. Okay. What we want to update some more characters inside the counter. How you can do that? C dot update, and we are passing A, B, C. Okay. So in this, if we print C again, you will get A count as 2, B as 3. Okay. And the program will see B is 3, A is 2, and C is 1 because C is now updated to its counter list. Or a different object of C can also be used with update function. I have two counter objects C1 and C2. Run the program, you will see we have two counter dictionaries. Okay, we want to update C1 with C2 and then print C1, you will get a new output. You see, B is now become 22 because 20 plus 2 equals to 22. A is now become 11. 10 plus 1 equals to 11. Now let's see iterating elements. Okay, I have a simple counter object. A is 3, B is 2, C is 0, and D equals to minus 2. There is element function on counter object that will actually iterate over element, repeating each as many times as it counts. Elements are written in the order first encountered. If an element's count is less than 1, so elements will ignore it. Okay, so what I am going to do, I'm going to take one S1 object, sorted, and will use C dot elements. Now if you print S1, you will get that A, 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 B, and B. Right? As definition set for this element function, it is going to ignore 0 or less than 0 counts. That's why we are getting A thrice, okay, and B only twice. Let's find now most common elements. So we will be using most underscore common function, okay. So counter can also find the most common elements in an iterable. The most underscore common function returns a list of elements and their count, sorted by count in an descending order, right? We have taken a list of integer values. Their values are repeated multiple times. Okay, we have created a counter instance here. If you print it first, you will get the same type of dictionary that 2's occurrence is 6 times, 1 occurrence is 3 times, 3 occurrence is thrice. So what we are going to do, we are going to use most common function. I have taken one new object, right? Counter object, that most common function we are going to use. If I print cmn object now, you will get that it would be in descending order. Means we have 2 which occurrences as 6. We have 1 which occurrences as 3 times. Okay, so is it has, so this most common function has written all the elements in list of tuples. Okay, if you take 0 and see type, what is the type, you'll get it's a tuple type. You see, so all the elements in this list written by most common function is type of tuple. If you want to get most specific common elements, then you can use one argument over here. I want to get only 3 elements which are most common. Run the program, you will get only 3 elements. You see, you can also get the least common objects by slicing the result of most common. Okay, what I'm going to do, I'm just going to get all the most common in a descending order, and I'm going to apply these slicing patterns. Okay, I have reversed the order of most common, which means I'm going to get first very least common element. Okay, run the program. So you will get 5 has one occurrence. Okay, now the order is reversed. Or if you want to get least common specific elements, then you have to just say -3 and then -1. What it will return? It will return two least common elements, right? Run the program. You see, we have only two least common element. With help of slicing, if you want to get most common, then you have to say 2 and then 1. So it will return you most common element, two elements. Let's use subtract function on counter instance. I have two counter objects, right? If you print the nt, it will get just a4 b2 like this. Okay, but if you want to subtract d from c, then you have to write c dot subtract and we have to pass d here and then just print c again, the c counter object in the program. So what will happen? We are getting 4 minus 1, that is 3, right? B 2 minus 2 equals to 0. Okay. C 0 minus 3, that becomes -3, and D minus 2 minus 4 becomes -6. That is how subtract function works. We also have a one very important function, that is total, which is for computing the sum of all counts. Okay, if you want to get the total of C, you will get a single value. When the program, you will get it is 4 because we have taken -2 as well. Let me remove it and then run the program. You will get that is 6. We are counting all the values of all the keys A and B. Now let's see some mathematical operation on counter objects. I have a simple code, a snippet to save some time. Okay, so these are the basic mathematical operation that we are performing on two counter objects. Okay, if you're in the program, you will get that C plus D, which means we are going to add their values with their exact key. 3 plus 1, that becomes 4. 1 plus 2, that becomes 3 in the first line. A minus operator that actually give us the result like 3 minus 1, that becomes 2. B, it is ignoring. Okay, then we have C and A, that is a intersection, that will going to return a minimum value of C and D, which means A equals to 1 and B equals to 1, A equals to 1 and then B equals to 1. Okay, then we used C or D, which is a union of these both counter objects. It is going to return the max value of these objects. It is 3 and B 2. A is 3 and B is 2. Those are max value in these elements. Equality, we are also checking. We are checking whether C is equals to D, which is returning false. It is not. Okay, and we are checking C is less than equals to D, that is also false. C is not less than to D. If we change a bit here, that A equals to 1 and B equals to 1, the results are going to be different. You see, now we are getting C is now equals to D, and even C is less than equals to D. You see, that brings us to the end of the today's video. We hope you found it informative and engaging. Don't forget to subscribe to our channel for more exciting content on all things tech related. Thanks for watching and we will see you in the next video.